Hello everyone, my name is Shweta Rao and I am a student of 3rd semester B Mechanical Department here at LG University, Ahmedabad. I am here to talk about my kinematics project. I made a differential mechanism model and my main motto with this project was to provide visual representation of how differential mechanism looks, how the parts of it are connected to one another and how it essentially works. Firstly, a brief explanation about differential mechanism and where it is essentially used. A differential is a mechanical device crucially found in the drivetrain of automobiles, responsible for the equitable distribution of power to the wheels. Its primary function is to enable the wheels to rotate at varying speeds, especially when a vehicle is taking corners or navigating uneven terrain. By permitting the speed differentiation, the differential ensures that each wheel can receive the appropriate amount of power while maintaining traction and stability. This essential component allows the vehicles to make smooth turns without the wheels skidding or causing excessive strain on the drivetrain of the vehicles. Differentials come in various types, including open differentials, limited slip differentials, and locking differentials, each catering to specific driving conditions and requirements. Differentials mainly use bevel gears. Now let's see the working methodology of the differential mechanism. The differential is located in the axial assembly and connects to the drive shaft or propeller shaft. It receives rotational power from the engine via propeller shaft. The differential's primary purpose is to allow the wheels to rotate at different speeds during turns. When vehicle takes a straight path, both wheels receive an equal amount of power. During a turn, the inside wheel travels a shorter distance than compared to the outside wheel, needing to rotate at a slower speed. The differential accommodates the speed difference by allowing the side gears to rotate at different rates. As the engine's power flows through the pinion gear, it turns the ring gear which is connected to the side gears. The spider gears located in the center of the differential enable the side gears to rotate independently. This differential action permits the wheels to rotate at varying speeds while maintaining traction and stability. This is how a differential mechanism works. This is the model that I made as a visual representation of differential mechanism. As shown in the part diagram, this shaft represents propeller shaft, the smaller bevel gear represents pinion gear, this bigger bevel gear represents speed reduction gear, or you can also call it ring gear. This red circular thing represents casting. Casting is mainly found in the real differentials, and in it is a spider mechanism. My project depicts a linear motion of the vehicles. Differential in automobiles have several other critical applications too. Steering and turning. It allows the wheels to rotate at different speeds when turning, ensuring smooth and stable cornering. Traction control. It distributes power to the wheels with the best traction to prevent wheel spin and improve grip, particularly in a slippery condition. Wheel stability. It helps maintaining stability and prevent excessive tire wear by accommodating variations in wheel speeds, reducing strain on the drivetrain. Off-roading, enabling all-wheel drive and four-wheel drive vehicles to handle uneven and challenging terrains, providing better control and traction. High performance driving. It enhances performance in sports cars and performance vehicles by optimizing power distribution to the wheels.